Good evening, dear all. So, welcome to another session of coordination chemistry. We were discussing about valence bond theory in the last sessions, right? And actually, we did some examples in six coordinate complexes, right? We discussed valence bond theory, that is the nature and bonding seen in six coordinate complexes. And I've also given you some assignments. And now I'm discussing one or two examples from those assignments. So first I am taking this example, that is chromium H2 6 times 3 plus. It is hexa aqua chromium 3, right? So first step is what? We have to find out the oxidation state of the central metal ion here. How can we do that? We can give X to whom? To the central metal atom. So we will give X to the central metal atom. Then we are having an H2O, right? So H2O is 0 charge. So we will give X plus 0 is equal to what? X plus 0 is equal to complex ion, the charge of the complex ion. It is 3 plus. So X is equal to what? X is equal to 3 plus, or chromium is in 3 plus oxidation state. Is that clear? Chromium is in 3 plus oxidation state. Now, let's see. What is the electronic configuration of chromium 3 plus? We know that if it is chromium alone, it is argon 3d5 4s1. These all we discussed in detail in last class, so I think you are well aware with this now. So 3d5 and 4s1. When it becomes chromium 3 plus, that is here the oxidation state of the central metal ion is 3 plus. So when it becomes chromium 3 plus, the outer electronic configuration becomes what? That is, we have to remove 3 electrons. Since it is 3 plus, we have to remove 3 outer electrons. That is 1 from 4s1 and 2 from 3d5. So that we'll get what? 3d3 and 4s0. So the outer electronic configuration of chromium 3 plus is Cr 3d3 and 4s0. You can see that here. Here it is of Cr alone. Here all the electrons are arranged in the 5d orbitals according to Hund's rule, and each one is singly filled, right? And a 4s1 is there. When it becomes Cr3 plus, we are removing the 3 outer electrons, and now we get 3d3 electronic configuration. Now the next step is we have to see who the ligand is. Who is the ligand? Here water is the ligand. We know it is a weak field ligand. So how many are there? It is 6. Obviously it's a 6 coordinate complex. So 6 ligands are approaching chromium or Cr3 plus. So how many orbitals we have to keep ready for them? How many hybrid orbitals we need? 6 hybrid orbitals, right? For 6 H2O ligands. 1, 2, 3, 4, 5 and 6. Okay, they are having 6 orbitals here itself. So what is the next step? These chromium 3 plus hybridize to form. That is, they go to the excited level to undergo hybridization to form what? 2D, that is D2, 1S, that is D2S and 3P, 1, 2, 3. So D2 sp3 hybrid orbitals. How many D2 sp3 hybrid orbitals will be formed? 1, 2, 3, 4, 5 and 6. That is 6 D2 sp3 hybrid orbitals of equivalent shape and energy will be formed. We know that if they are staying as D, S and P, they will be having different energies, but they undergo hybridization for what? For making all their energies and shapes equivalent, so that they can easily overlap with the orbitals of the ligands approaching. So that is why hybridization is happening, and here it is 1, 2, 3, 4, 5, 6. So 6 D2 sp3 hybrid orbitals are formed, and the next step, the approaching ligands donate their electron pairs to these D2 sp3 hybrid orbitals, 1 pair to each orbital, so that there becomes a total of 6 bonds between the water and the Cr3 plus, or the ligand and the central metal ion. 1, 2, 3, 4, 5, 6. Because it is a 6 coordinate complex, or 6 ligands are approaching with 12 pair of electrons. See, 12 electrons or 6 pair of electrons. See, these are all electrons donated by the ligands to the central metal. Thus, through this overlapping of bonds, overlapping of the orbitals, the complex is formed. So this is the nature of bonding seen in CrH2O 6 times 3 plus according to what? Valence bond theory. This is how they explain the nature of bonding. So what are the points we can write here? we now know the hybridization. What is it? D2sp3 hybridization. If it is D2sp3, it is forming what kind of complexes? The geometry will be definitely octahedral geometry, or they are forming an octahedral complex. Then are they forming inner orbital complex or outer orbital complex? This also we detailed in the last sessions. Since the inner d orbitals are involved in the hybridization, they are forming a inner orbital complex. If it was the outer d electrons which were involved, that is, if it were the 4d electrons which were involved, then they should have formed what? An outer orbital complex. But here the inner d orbitals are available for what? Hybridization. So the complex is what? Inner orbital complex. The next point is that they are forming a low spin complex. And then we have to speak about the magnetic property of the complex, and it is paramagnetic. Why? Because it contains unpaired electrons. It is paramagnetic in nature. So these are the properties associated with what? CrH2O 6 times 3 plus according to valence bond theory. Explanation given to the nature of bonding in the given complex according to valence bond theory. So all these points you have to keep in mind. Now we'll move on to the next complex. Another 6-coordinate complex I have taken as an example. It is CrCO 6 times, right? It is a neutral complex. So what is the oxidation state here?